Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is Introduction to Trigonometry. This is the second video on this particular topic. The first video covered a basic definition of trigonometric angles such as sine, cosine, tangent, cosecant, secant and cot angles. We also introduce you to the basic trigonometric identities which were sine square theta plus cos square theta equal to 1 plus tan square theta equal to secant square theta and 1 plus cot square theta equal to cosecant square theta. Then different trigonometric angles, the value of sine, cosine and tangent were also defined at particular angles such as 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Then few problems were also introduced in that video. You can watch that video whose link is given in the description box. In this particular video, we will be more examination oriented and we call it as extra punch problems or the hot questions. So pay attention here students and be ready with pen and paper. From the figure, we have to find the values of sin x and cos y. So this is the particular figure. Let us examine this figure. There are two right angles given in this figure. So this right angle is for this triangle CAB and this right angle is for CPD triangle. Now we have to find sin x. Let us find sin x here first. This is in this triangle CBD, which is right angle at angle D. So what will be the hypotenuse? Hypotenuse will be opposite to the right angle. So side CB is the hypotenuse. These two are the other two sides of the triangle given by length 3 cm and 4 cm respectively. Now to find sin x, we know the formula, it is opposite side by hypotenuse. So opposite side to sin x is side BD. So and divided by hypotenuse. So sin x will be BD by BC, that is opposite side by hypotenuse. But BC is not given here. And this being a right angle triangle, this is the hypotenuse. So we can apply the Pythagoras theorem to get BC. BC square is BD square plus DC square. So BC will be square root of 3 square plus 4 square. 9 plus 16, 25. Square root will be 5. So BC will be 5. So now it is easy to find. Sin x is opposite side by hypotenuse, which is 4 by 5. Now let us find cos y. Cos y is adjacent side by hypotenuse. This is the right angle here, so opposite is the hypotenuse. CA is the hypotenuse. So cos y will be AB by AC. Again AC is not given here, but the other two sides are given 12 cm and we just evaluated BC as 5 cm. Again applying the Pythagoras rule, we get AC equal to square root of 12 square plus 5 square. This is 144 plus 25, 169, square root of that will be 30. So cos y will be 12 by 30. In this particular problem, we are given a right angle triangle at C and tan A is given by 1 by root 3 and tan B equal to root 3. We have to find this particular identity. We have to show this particular identity. Now let us find tan A. Tan A definition is opposite side by hypotenuse. If this is the tan A, opposite side is BC and adjacent side is AC. So tan A is BC by AC equal to 1 over root 3. So we can write BC as 1 unit and AC as root 3 units. Similarly, tan B, if we observe, will be AC by BC. Tan B is opposite side by adjacent side, which is root 3 by 1. So this is correct. Already it is given. So this BC equal to 1 unit and AC equal to root 3 unit is correct. Now let us find AB. AB is again by Pythagoras theorem square root BC square plus AC square. So BC square is 1 square, AC square is root 3 square. So 1 square is 1, root 3 square is 3, 3 plus 1 is 4, square root 4 is 2. Let us find now all these trigonometric values. So sine A is opposite side by hypotenuse. Opposite side is BC, hypotenuse is AB. So this is 1 by 2. Cos B is adjacent side by hypotenuse. So 1 over 2. BC by AB. Similarly, we can find cos A and sin B. Now, let us put these values in this particular equation which we want to determine. So, we put sin A as half, cos B as half, plus root 3 by 2 into root 3 by 2, 1 by 2 into 1 by 2 is 1 by 4, root 3 into root 3 is 3, so this is 3 by 4, 1 by 4 plus 3 by 4 is 1. So the value of this expression is shown to be 1. Let us take another problem. In this we are given sin theta as 1 by 3. We need to find tan theta. So what is tan theta is sin theta by cos theta. So sin theta is already given. We need to now write cos theta in terms of sin theta. So we know the trigonometric identity sin square theta plus cos square theta is equal to 1. So cos square theta is equal to 1 minus sin square theta. So cos theta is square root of 1 minus sin square theta. Why we are doing this? Because we are given sin theta only. So we are writing cos theta also in terms of sin theta. Now we substitute this in this particular equation. So tan theta is sin theta by square root of 1 minus sin square theta. All the RHS is now in terms of sin theta, which value is given. So we can get tan theta. Putting this 1 by 3 by square root of 1 minus 1 by 3 the whole square, which is 1 over 9. Evaluating this or simplifying this, we get 1 over root 8. This is the final answer. In this particular problem, we are given tan theta plus sin theta as m, and tan theta minus sin theta is equal to n. We need to show that m square plus n square is 4 square root mn. Now we'll take LHS first and try to substitute m and n from this particular equations. So LHS is m square minus n square, and we put tan theta plus sin theta the whole square minus tan theta minus sin theta the whole square. We are just substituting m and n by these values. Let us simplify this. So this will be tan square theta plus sin square theta plus 2 tan theta sin theta. And this will be tan square theta plus sin square theta minus 2 tan theta sin theta. When we open the bracket, this will become minus tan square theta, which will get cancelled with this. This will get cancelled. Similarly, sin square theta minus sin square theta also will get cancelled, and this will become plus sign. So we will add with this. So this is already plus 2 sin 2 tan theta. This is plus 2 tan theta sin theta. We will add that. So it will become 4 tan theta sin theta. Now we cannot simplify this further. So we will stop here and check for RHS. What happens if we put m and n as these values? So in the RHS, we know 4 square root mn. We put the values of m and n. Tan theta plus sin theta into tan theta minus sin theta. So this is a plus b into a minus b, which is a square minus b square. So this will become tan square theta minus sin square theta. What is tan square theta? It is sin square theta by cos square theta. Already minus sin square theta, remaining term we are putting. Now we take LCM, cos square theta. So it will be sin square theta minus sin square theta into cos square theta. We can take sin square theta as common. So this will be 1 minus cos square theta by cos square theta. What is 1 minus cos square theta? It is sine square theta by basic trigonometric identity. So we multiply sine square theta into sine square theta, which is sine to the power 4 theta divided by cos square theta. 4 is already there. When we take out the square root, sine 4 theta will be sine square theta and cos square theta will be cos theta. We again break up this. This we can break it up as sine theta into sine theta. So we write it as 4 sine theta by cos theta and remaining sine theta. What is sine theta by cos theta? It's tan theta. So 4 tan theta sine theta. This what exactly we got it as on the LHS. So we see that LHS and RHS are same, hence we have shown this. In this particular problem, we are given that 7 sine square theta plus 3 cos square theta is equal to 4. Then we need to show tan theta is equal to 1 by square root 3. Now once we see this problem, we see that we are on the LHS, we have sine square theta plus cos square theta. So it should give some clue that on the RHS also, if we can write in terms of sine square theta and cos square theta, then probably we can simplify. This is the only way to proceed. So we can write RHS as 4 into 1. So we can write this LHS equal to 4 into 1. So what is 1? 1 can be written in terms of sine square theta plus cos square theta, which we know is 1. So we have written 4 as 4 into sine square theta plus cos square theta. Because on LHS also we have sine square theta plus cos square theta. That is the intention. So on simplifying, we see that this is 7 sine square theta, it is 4 sine square theta. So we are left with 3 sine square theta. Here 3 cos square theta, here we have 4 cos square theta. If we take this on the RHS, this will be cos square theta. So let us cross multiply and this will be sine square theta by cos square theta, which is nothing but tan square theta. That's what we require. We should keep an eye on what is required. So tan square theta will be 1 over 3 if we cross multiply this. So what is tan theta? By taking square root on both sides, we get tan theta equal to 1 by square root 3. So that's what we have proved this. In this particular problem, we are given if sec theta is x plus 1 by 4x, then show that sec theta plus tan theta is equal to 2x or 1 over 2x. So how do we approach? This we need to compute sec theta plus tan theta. Sec theta is already given. So we have to write or get tan theta. Since sec theta is there, we know the trigonometric identity 1 plus tan square theta equal to sec square theta. So first we square this and try to get tan theta. So once we square this, we get x plus 1 by 4x the whole square, just squaring. So writing this as 1 plus tan square theta equal to RHS already given. So we want tan theta, so we'll keep tan square theta here and take minus 1 on the other side. So we are left with x plus 1 by 4x the whole square minus 1. Let us expand this. So this will be x square plus 1 by 4x the whole square and we multiply 2ab. 2 into x into 1 by 4x is 1 by 2. Minus 1 is the balance term. If we observe, and this becomes minus half. So if we expand this, or if we want to find square of this, we know that this particular term will be x minus 1 by 4x the whole square. Now we have minus half instead of plus half, so here it becomes minus sign. You can check it with yourself, this particular thing. We can expand here like x square plus 1 by 4x the whole square minus 2x into 1 by 4x is minus half. So we take the square root on both sides, we get tan theta is plus minus x minus 1 by 4x. If you are new to this symbol, what is plus minus? Then it is already explained in the previous video. We'll just give an introduction here that if z square is 9, then z will be plus minus 3. It means z can be plus or z can be minus. Let us put here z equal to plus 3. So z square will be 9. If you put minus 3, so again z square will be 9. So it means z takes both either positive 3 or a negative 3. Similarly, on that basis, we have written tan theta is plus minus x minus 1 by 4x. Whenever we take the square root, here we have taken square root. Z square square, it was z. 9 square root is 3. We add the term plus minus. So similarly, we have added plus minus here. Now we got tan theta. Sec theta is already given. So we can compute this. So sec theta plus tan theta is x plus 4x already given. Plus minus, we add x minus 4x. So let us start with plus value first. If we take plus here, then 1 by 4x and minus 1 by 4x will get cancelled. This term will get cancelled and we will be left with 2x. Similarly, if you put minus sign here, x and minus x will get cancelled and this term will become positive. So 1 by 4x plus 1 by 4x will be 1 over 2x. So this we are able to show now. In this particular problem, we are given sine theta plus cos theta as root 3. Then we need to find the value of tan theta plus cot theta. Now, how do we proceed? It looks tempting to first square this side so that square root term also can go. So let us try that way. So squaring on both sides will give sine theta plus cos theta the whole square is equal to 3. We expand this. So sine square theta plus cos square theta plus 2 sine theta cos theta is equal to 3. What is sine square theta plus cos square theta? This is 1. So 1 will take it on the RHS. So this will become 3 minus 1, 2. So we are left with 2 sine theta cos theta is equal to 2. Now just cross multiply, we get 1 is equal to 1 over sine theta by cos theta. What is 1? 1 we can write it as sine square theta plus cos square theta by sine theta cos theta. Let us break into two individual terms. So this will be sine square theta by sine theta cos theta plus cos square theta by sine theta cos theta. On simplification we get sine theta by cos theta plus cos theta by sine theta. This is tan theta and this is cot theta. So we have an eye on the what is required. So we get tan theta plus cot theta as 1. This is the final answer. In this particular problem, we have to prove that 1 plus 1 over tan square theta into 1 plus 1 over cot square theta is equal to 1 over cos square theta minus cos to the power 4 theta. Now let us see here. 1 over tan theta we know is cot theta. So 1 over tan square theta is cot square theta. And what is 1 over cot theta is tan theta. So 1 over cot square theta is tan square theta. So we are writing this as this term, particular term will be cot square theta and this particular term will be tan square theta. So we can write it as 1 plus cot square theta into 1 plus tan square theta. So 1 plus tan square theta we know, identity, basic trigonometric identity is sec square theta. Similarly 1 plus cot square theta is cosec square theta. So we write that. So what is cosec? Cosec square theta is 1 over sine square theta and what is sec square theta? 1 over cos square theta. So we can write this as 1 over sine square theta into cos square theta. What is sine square theta? From the basic trigonometric identity we know that sine square theta is 1 minus cos square theta into cos square theta. So multiplying we get cos square theta minus cos to the power 4 theta. This is what is required. In this particular problem, we are given x is as a sine theta and y as b tan theta. We need to prove that a square by x square minus b square by y square is 1. So how do we proceed? In this particular equation, we will substitute x with this a sine theta and y by b tan theta. So let us substitute that. So we will get a square by a square sine square theta. X square is a sine theta. So x square will be a square sine square theta minus b square by y is b tan theta. So this will be b square tan square theta. A square term will be cancelled. So we'll be left with 1 by sine square theta. B square term will also get cancelled. So we'll be left with 1 over tan square theta, which is nothing but cos square theta by sine square theta. So we'll take a LCM sine square theta. We'll get 1 minus cos square theta, and 1 minus cos square theta is nothing but sine square theta. So we'll get sine square theta by sine square theta, which is 1. And hence it is proved. With this we conclude this chapter. I request you friends to please subscribe my channel. This will motivate me to make more such good videos for you, and it can be released to you immediately on release. Thank you very much friends.